Hello, this is video 43, and believe it or not, we are still talking about conditions. This is a multi-part story here. Let's, this time, using conditions, C-O-N-D-S, that's my abbreviation, using conditions to repeat statements. Up to this point, we've seen how to skip them. We haven't seen how to do them more than once. The statement that's used for this is the while loop, W-H-I-L-E, while loop. And loop means it goes around in a circle over and over and over. The format for this is the word while, which changes the special color in the editor because that's a reserved word. The editor knows it too. While, and then a condition, just like we had on the if statement. And then a colon, just like we had on the if statement. So far, the only thing different is we ripped out the word if and put in the word while. Indented statements beneath here, I'm going to label these as STMTS capital L for statements loop. Not statements true, not statements false, but statements loop. The effect of this is going to look a little complicated, but I'll see if I can fill in or erase some of the complication with adequate explanation. I'm going to dent a little bit myself and then say computer or the CPU evaluates the condition. Evals the condition. C-O-N-D. Let me read that back. CPU, the part that's actually executing our program, the hardware part, CPU evaluates the condition. And then, I'm indenting here, true? Did the condition turn out to be true? Then these things happen. Then statements L, S-T-N-T-S, capital L is executed. By whom? Who executes it? The CPU, E-X-E-C-U-T-E-D. Anytime I say is executed on the board, I'm talking about probably statements and probably the CPU. So statements L is executed by the CPU. Here's the new part. Up to this point, that's very similar to the format for if format 1, if I recall. Now it gets different. Computer, or the CPU, goes back to top, which I'll put in a box. And that's why I indented way up here, top. That's not typed in anywhere. You don't see that in the lines of your program. It's just that here I've got something I can talk about in my description of the format. I told you I was going to have to do some explanation. Let me finish this and then I'll talk about the explanation a little more. What if it evaluates the condition is false? We don't have an else with the loop. Then this happens. The CPU skips to the next statement after statements L. A lot of writing with no talking. Let me see if I can read this back and make any sense out of it. At the top, here's the first line of our while loop. At the very top up here with the while, the CPU evaluates this condition it sees up here. If that condition is true, then two things happen. It executes all these indented statements, and this happens automatically. There is no special statement that says, go back up there. It goes back up there automatically when it finishes the indented statements. That's why it's a loop. That's why it's called a loop. The CPU goes back to the top up here and evaluates the condition all over again. It's checking the same condition over and over and over. What if it gets to this line and the condition is false? There's no else part, but if it's false, then the CPU skips to the next statement after these. There, it's very much like a format 1 if statement. There's actually a term for what happens here. I'll put this in parentheses. It falls out of the loop. And you might think, how can it fall out if the condition was false and it was never in the loop? Well, here's the deal. The condition might be true several times, condition, 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 always true, 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 true. And then eventually it turns false somehow. It better. When it turns false, then it falls out. The CPU falls out of the loop and continues on with your program, executing statements that are executing statements that are after the indented statements underneath the while statement. This is one of those things, I bet you can tell already, this is one of those things that is going to be cleared up, I hope, a lot more by looking at an example. So here's my blue example of this. And this is probably not top of the program, dot, dot, dot. We come down here, count, C-O-U-N-T, equals 0. And then instead of an if, while, W-H-I-L-E, while count is less than 3, colon. That looks like a heart emoji, doesn't it? Let me scoot the 3 over. While count is less than 3, colon, indent, here's statement cell, print. I'm actually going to print a couple of things. Double quote, strike, close double quotes, and then after a comma, count plus 1. I barely had room to squeeze that in there. Let me read that back. The first indented statement inside statements L is a print statement. Print the string strike, enclosed in double quotes. This is a character string. A comma, and then count plus 1 is what that says. Count plus 1. Then, next line is an assignment statement that says count equals count plus 1. This is just an expression. It just says count plus 1. That's what I want to see printed to the screen. This is an activity. This is an assignment. It's making things happen, changing the value of the variable. Then when I fall out of the loop, I'll use that expression already, fall out of the loop and unindent, I'm going to do another print statement. Print, double quote, you're out. Exclamation point. Now, inside this quoted string, it's okay for me to use a single quote. That's just part of the string. I don't want to use a double quote here, or that chops off the string early, and I'll probably get an error message. Okay. Let me switch colors. Find one that will work. I hadn't used brown in a long time. Hope this works. Please, oh please. That's decent. Okay, here's my trace. And here we come, merrily along, count. Initially, I don't know. So I put a question mark. I don't know what count is. But when I get to this far, well, I need dots down here, don't I? That's not the whole program. When I get this far, this is going to take 0 and put that in variable count. So now I know what it is. Count is 0. No question about it. Here's the while statement with a condition. While count less than 3. Looks up the value of count. Count is 0. 0 is less than 3. So this is going to generate some output. The output. Print strike, S-T-R-I-K-E. And the value of this expression, now I'll say it again, count plus 1, it looks like I'm adding 1 to count in memory, but I am not. This is just an expression. Go look up the value of variable count, add 1 to it, print that to the screen, but that will not change the value of count. Count plus 1. Count is currently 0. 0 plus 1 is 1. So it prints out strike 1. Next line, still inside the while loop. Count plus 1 on the right-hand side. Here's where it gets changed. 0 plus 1 is 1. That becomes the new value of count. 1. Now here's the moment of truth. Looking at this effect over here. This is where the CPU goes back to the top. It's now done all the indented statements inside the while loop without us doing anything at all special. It goes back up and checks the condition all over again. This is the top of the while loop. It goes back up and asks the question again, is it true that count is still less than 3? While count is less than 3? Yes, it is. 1 is less than 3, so here we go again. All over again. It prints out strike, followed by the value of count plus 1. The value of count is now 1. 1 plus 1 is 2. It prints out 2. Then it hits this assignment statement, also called an increment statement because we're incrementing count by 1. On the right-hand side, count is 1 now. 1 plus 1 is 2, and we make it permanent. We put the 2 over here in variable count. count has value 2. We're still inside the loop. It still goes back up to the top. Checks the condition again. Is count less than 3? Yes, it is. Here we go. Strike. The value of count is 2. 2 plus 1 is 3. It prints out strike 3. Count equals count plus 1. Count is 2. 2 plus 1 is 3. That becomes a new value of variable count. It still goes back to the top of the while loop all over again. Every time it gets to the bottom of the indented statements, it will go back up to the top and reevaluate the condition. Look what happens this time, though. While count is less than 3. Well, count is 3. 3 is not less than 3. So it falls out of the loop and does whatever follows. False. The CPU skips to the next statement after the indented statements. The next statement after the indented statements prints out you're out. You're out! Exclamation point. And that's it. It doesn't add 1 to make count 4 or anything like that. It doesn't do either one of those statements. Done and done on the loop. Okay? I filled up the whole board. I'm not going to make you watch me erase it. So I'll be back in just a minute. I'll see you online.